Page 11, problem number 5, and this will be an extended mole train problem. We'll also show it through a chart style method as well. All right, let's identify what we know, see what we don't know, and go about solving this problem. So we get a little marker here, and I see I have 10 grams someplace. How many grams of chlorine must be reacted with excess sodium iodide to make 10 grams of sodium chloride in a single displacement reaction? How many grams of chlorine gas? Ooh, this looks like chlorine gas. Maybe I'm going to put a question mark right there. So I might put question mark, and then I might put G for grams right there. Okay, we don't know how many grams of chlorine. And then what I'm going to do is, I think it was about NaCl. It says I have 10 grams of that. So I'm going to do 10.0 right there. Now I notice it did say something here. It said this was excess or in excess. I'm just going to write that right there and maybe draw this thing back over here. So this is just some of the information I picked from this equation. Oh, I have an equation. I probably should balance it. I got 2 chlorines there. So what does that tell me? I better put a 2 in front here. Now I got 2 sodiums. I'm going to put a 2 in front right here. And this will be a 1. This will be a 1. Okay, I would probably put a G there for grams because this was grams. So I'm starting with 10 grams of sodium chloride. I'm trying to find out how many grams of chlorine gas. What does this excess mean? Well, it's kind of like if I'm trying to make a certain number of sandwiches and I want to know how much cheese, and I just say, oh, I have excess bread. It means that you have enough bread to make the sandwiches, so you don't have to worry about it. In this case, we have enough sodium iodide to react with this amount of chlorine that we're concerned about. So we're only going to compare this 10 grams of sodium chloride to this question mark of Cl2. If I were doing a mole train, I go and put what I know on the bottom, and I know the mass of it. So I'm going to put a little star there because I know the mass. And what am I going to put here? I'm going to write this in. This bottom train is going to be the NaCl train. Okay, so that's the salt train right there, or NaCl. The top train is going to be what I don't know, which will be Cl2. So I'm going to put this in right here, call this Cl2. And what do I not know about this is the mass. So I'm going to put a big question mark or 2 question marks right there just for emphasis. But this is what I'm trying to figure out. So this looks like a typical mass to mass problem. And you can't go straight there because the balance equation doesn't compare grams. You have to go grams to moles to moles, and moles to grams. That's why there's 1, 2, 3 steps right here. So we're going to model that process. And the first thing I'm going to do is take my 10 grams of NaCl, which we know. The next stop is to go to moles. So we're going over here. How do we go from grams to moles? We divide by the molar mass. So I take the molar mass of Cl2, which I think I kind of figured out, and I threw it up here. Cl2 is 71.0 grams per mole, 2 times 35.5. So I'm going to steal that little piece of information, come back down here, and let's see, I think we're back locked in, and let's solve this. So I'm coming from grams of NaCl, so I'm going to put grams of NaCl on the bottom. So the grams NaCl on the bottom, and I'm going to put moles of NaCl on top. And what's the molar mass? We said it was 58.5. It is 58.5 grams in a mole, or moles in a gram. If 58.5 goes on the bottom. So this is a 1. And then on the bottom, we have the 58.5. So the mole train tells us to divide. This would be right. Mass to moles, we divide by the molar mass. So 10 divided by 58.5 would be my first step. The next step is to go between moles and moles. We look at the balanced equation, and we're going to look at this coefficient and this coefficient because those are the 2 things we're comparing. The thing we know goes on the bottom. So we know the Cl2, I'm sorry, the thing we know goes on bottom. And even though it's a product, I'm going to put the NaCl on the bottom. So let's do that. And I'm going to put moles of NaCl on the bottom. And I'm going to put moles of what I don't know, what I'm trying to find out, moles of Cl2 on top. So even though this is a product, it's what I know, so it goes on the bottom. This is a reactant, so it goes on top. So the 2 goes on the bottom, the 1 goes on the top. And let's fill that in. So the 1 goes with the Cl2, the 2 goes with the NaCl. That's not capitalized, but I think we get what's going on there. Okay, so now we've gone from here to here. We've done this step right now. We've gone through the balance equation to get to moles. The last step is to go through the molar mass. What is the molar mass of NaCl? I pre-did that. 1 Na is 23. 1 Cl is 35.5. I add them, I get 58.5 for my molar mass. And what does it say to do with the molar mass? It says to multiply, making me think that the grams are going to be on top. I'm just going to draw this in. I'm coming from moles of Cl2. So I'm going to put moles of Cl2 on the bottom. And I'm going to put grams of Cl2 on top. And what did we say? We said it was 58.5 grams in a mole. So the 58.5 will go here. We have enough room for that. Okay, a little tight. It looks like it works. And then this would be 1 mole. So I'm sorry, that's not the right molar mass of NaCl. And I did this backwards. The molar mass of Cl2 is 71.0. I think I kind of messed this whole thing up. Let's retake a look at it. So I started over here with the molar mass of NaCl, 58.5. I end with the molar mass of Cl2, which would be 71. Let's go back and look at our work. Okay, for that. So there is the molar mass of NaCl, 58.5, and there is the molar mass of Cl2 is 71. I think I mentioned that backwards when I put things in. So NaCl is 58.5, Cl2 is going to be 71. So let's see if we did this right. It looks pretty good. I put the 58.5 with the molar mass of NaCl. I put the 71.0 by the Cl2. So ultimately 10 divided by 58.5 divided by 2 times 71, and I end up with the value of 6.07 grams. I'm just going to write that in here. 6.07, and that would be Cl2 at the end. All right, so that is a mole train problem for solving this. Figure out where you're at, following the mole train, figure out where you're going. And what about using a chart style for this process? I'm just going to demonstrate that right here and should be able to do that quite a bit more quickly because we have a lot of the components already made up. So I'm going to take this, and I think I'm going to have to lose this other part, and I think it will be okay to do that. So we're going to look at our reaction right here, and I'm going to clear this out, and I'm going to write out what I know, which was we had 10 grams of NaCl. So I'm going to identify this as my starting point, 10.0. And I think I was trying to find what question mark grams right here. All right, so 10 grams, question mark grams. And let's see. And I'm afraid I shouldn't do this at the same thing. I'm going to run into trouble here. So do this one more time and put 10 grams here as my starting point. And then what I'm going to do is my ending point is going to be question mark grams right here. And we know that that's grams. Okay, it says grams right there. Okay, next thing is we are going to, now do we have to do this column or this column? No, we're only going to concern ourselves with these columns. I could go back to the top and I can find my molar masses because we solved for them up here. So do a quick scroll, and what do we find? So I'm just going to type in, we know this is 71.0. We figured that out in the last problem, and we said this was 58.5. So I'm going to write 58.5 in, and we know this is grams per mole. Now, we were given this is what we're trying to find. Let's see. Oh, we better write our balanced equation. So we said this was a 1 and a 2 and a 2 and a 1. Okay, so we're going 10 divided by 58.5, and I'm going to punch that in. And that equals 0.171. And I'm going to keep 3 figures on this. So if you're using this and you get real small numbers, you should keep the figures there. So I'm going to say 0.171 moles. Okay. Now, when I go from here to here, I'm coming from the 2 going to the 1. So it's going to be half as much. So I'm going to take this number, divide by 2, and that gives me 0.0855. So 0, and notice it's a small number, but I'm going to keep all the figures. 0.0855 is going to go there. So this number, 2 is twice as big as 1, 0.171 is twice as big as this. Now, if 10 divided by 58 equals this times this would equal this, or 0.0855 times 71, okay, would be, and we'll see what it is, and it looks like I get 6.07 grams. So I could write 6.07. If you get a problem and you end up using a chart style like this, you circle this and actually bring this answer out and then say 6.07 grams of Cl2. So your reader will know you're not just filling in boxes, but you understand your work and that you're able to answer the question right here. So notice the same answer. This would be a modified chart style, just dealing with the 2 columns that you need to deal with to answer this question. Hope that helps. Let me know if you have questions. Thank you.